Well, I really hope the audio is being recorded. Maybe I should just have a backup plan. The issue is, so I have a laptop, but the issue is the display adapter for the laptop is not working correctly. Where do I put my microphone? Okay, can you guys hear me? Is this okay? All right. Okay, all right. Well, happy Monday and welcome back to campus, those of you who are here. And I just want to give you a friendly reminder to make sure you have all filled out that symptom monitoring survey. And if you forgot to do that, you can go ahead and do that right now. But have to make sure we are in compliance. Where is sound recorder on my? I don't even know if I have a sound recorder device on here. Okay. Maybe not. All right. Well, I'm just hoping this thing is recording audio. Otherwise, we're in a bit of a pinch here. Okay. Well, today's lecture, week 5, Monday. Sorry, I'm getting, just trying to get everything set up here. Okay. It's titled Working with Files. And so we are going to look at exactly that. Okay, so this concept of persistence is often important in that, every time you start, you open up a new Jupyter notebook, it starts off completely clean. There's no variables loaded in, nothing like that, right? So if you want to use NumPy, pandas, you got to import those in fresh. If you want any kind of values loaded in, you've got to you have to either create them, and sometimes it's a pain. And so we have this idea of things being persistent, meaning that we need to be able to store their data somewhere. Okay, and so today we're going to look at reading and writing files. And the very first thing we can do is we can use open. Okay, so we can we open a file using just this this command open, and this allows us to kind of just read a file, and it's the idea of opening a connection to a file. And if you use the argument W, this connection kind of goes both ways. Not only can you read the data in, you can also write to it. Okay, so basically, if you want to write stuff to it, it will do that. Now, if this file exists and you call it in like this, running this command is going to just replace whatever's there. Okay, so don't run this command if you need to kind of keep that stuff there. So so here I'm going to just create the variable called fileout, fout, and we're going to open a connection to output.txt. And this is going to create a file inside my working directory called output.txt. And it's a writable connection. So basically, now that I've called this, whatever used to be an output.txt, it's like it might as well be gone now, okay? Because we're writing straight to it, okay? So this creates an object that allows us to write to it, and basically, I can just write lines to it. So there's fout. One of the methods associated with this kind of object is the .write, and so it says, here's the I just created a string that says this is the first line of text. Notice I include a /n to put in a new line character. And I'm so excited I get to use my pointing stick here. Okay, and it says f.out write and 32, indicating that apparently I've written 32 characters to this string. Okay, and that's what it says. Okay, so it writes that line to the text file. Okay, if you call it again, it's going to add new data to the end of the file. All right, so here's this is the second line of text, fout.write. Let me so this file exists, and here we go. And so the file output.txt, it now contains these two lines of text. This is the first line of text. This is the second line of text, right? So this will be the second line of text. It writes that out, and then when you're done, you close the file. Okay, you close the file, and I don't know if have you guys been properly shutting down and exiting Jupyter, or do you just close the terminal after you're done? So when you're in Jupyter, when you want to close a notebook, you should go to within the Jupyter window. There's like a file, shut down and close notebook, and that, you know, you got these clock cycles dedicated to the notebook. As your computer's probably super fast and it doesn't care. But I mean, if you're like if you do like Jupyter notebooks on like say an Amazon web server or something where you have to like pay for, you know, clock usage, you don't want to leave your notebook open where it's just going to keep billing to your account, right? So you want to make sure you do shut down each of these things. But anyway, so when you're done writing to the file, you close that connection, and it frees up the system resources, right? And if you forget to do it, and there's no names bound to it, Python has kind of this automatic garbage collector, which is really nice, and it just kind of cleans up stuff. I don't know if you've ever used like C or something where you have to like make sure you clean up your memory yourself. It's much more work. Python makes a lot of things easier for us. Okay, there's something called with. All right, with basically opens the thing, and then when it's done, it closes the thing for us. All right, so we do with open this connection, and then as soon as it's done, all right, as soon as it reaches the end of that code chunk or that code block with the indentation of with, it's going to close it. Okay, 5 and 6 basically do the same type of thing, where we have this. Okay, I'm sorry. 5 reads it, and then number 6, 5 writes to it, and number 6 will then read it. Okay, so notice for number 6, for number 5, I have the W to say I want to write to the file. It goes through and it writes line 1 and it writes line 2, and then it closes the connection. So if I want to access this stuff in the file again, I got to open it up again. Okay, so this time I'm going to open it up here. This time I'm opening it in R mode, read mode, rather than write mode. And then I'm going to go through as file, okay, right here. This is going to be an iterable where each line is the iterable object. So it's going to just be for I. So basically line I in the file. So print line I, prints out the first line of text. Then it prints out the second line of text. And if you had 1,000 lines of text, it would iterate through each of these things. Okay. So if you have a big text book or something, that's how we do it. All right. Let me give you your first view quiz answer. And I really hope this thing is recording. I don't know. It's really strange seeing yourself on the screen here. But okay, first view quiz answer is A. A as in apple. A as in apple is our first view quiz answer. And hopefully I'll get this display adapter sorted out by our next meeting. When you use write, the argument that we pass to it, so notice when I do file.write and it says line 1, whatever I pass to it has to be a string. Okay? If it's not a string, the easiest way to convert something into a string is just to use str. Okay? And then if you don't convert values to strings, you run into problems. So for example, let's say you wanted to say something like 42.3 is my favorite number. which is a strange favorite number, but let's say that's what it is. You can try doing, I want to join these two together using the plus operator. So we say y is equal to x plus is my favorite number. Python complains and says, x is a float, the other part's a string, and I don't know how to add these two together. So simple enough, we say, all right, let's turn 42.3 into a string. We'll do string plus string, and then Python can join those two together, right? Strings are kind of like iterables in that when you use the plus operator, it extends them. Okay. Another option to kind of deal with strings is to use the curly brace replacement fields. All right. And you use the replacement fields as kind of placeholders for wherever you want to put a variable into the string. All right. Python has its own little format specification mini language, which is how we handle these replacement string things. So I'm just going to go over some basics here. And then if you have some more interest, you do check out that link. Okay. So here, I've changed my mind. 12.2.34. We're going to say that's my favorite number. I feel like over here, I don't know, the audio walking around the classroom. I don't know what's going on. Here I just put in a curly brace, all right? And this is going to be the box where any variables go in. So I put in the curly brace is my favorite number, the string, and then I say dot format. I don't know, maybe I should just use the mouse. Dot format. Oh, I can't. It's a touch screen. Okay. Dot format, and then so the x currently has the value 12.34, and so it's going to take that number 12.34, put it in that replacement field, and then so if I say and y becomes that string, and so I say print y, and it comes out with a string. 12.34 is my favorite number. Okay. You can have multiple replacement fields, and inside dot format you pass it a tuple. All right. So here I got x is 12.34, x2 37.8, right? And I'm going to say blank curly brace. Curly brace field is my favorite number, and curly brace field is my second favorite number. And I pass dot format a tuple, and it just takes those things and it puts them in. Okay. You can also, if you're going to do something kind of complex, you can also put indices inside the replacement fields. Okay. I got a 1, a 0, and a 1. All right. And so now I pass it the tuple with x and x2. And wherever it sees index 1, it's going to put in the value at x2. Whenever it sees index 0, it's going to put in the value at x. So there, because I put index 1 is my favorite number, it's going to come out 37.8 is my favorite number. Index 0, 12.34 is my second favorite number. And then it goes, again, my favorite number is the value at index 1. All right. And you can imagine whatever scenarios you want. This is also how we format numbers into certain things. So here I put in all of these decimal places. All right. You add in after the index value. Okay. So I have, so notice my replacement field is 0:G. Okay. The 0 is basically the index value that says which number I want to put in there. And the :G is I want it's formatted. I want it printed out in a certain way. All right. So G is for general number format. This is probably good enough in a lot of cases. And the default is it's going to print 6 significant figures. And I think it's around 10 to the -5 when it switches over from regular to scientific printing. So you'll notice X is actually 0.00012345678 and then because it's only printing 6 significant figures, it says 0.000123457. It rounds off that 6th number. Okay, and then similarly X2, I've got 0.00012345678 and here I put in .8G. The .8 means 8 figures after the dot. Okay, 8 significant figures. I guess not after the dot. Just eight figures total. Okay, and so now it goes 1, 2, 3, 4, 5, 6, 7, and then at the 8th, it rounds off to 9 here. Yeah.
Is the actually print out, or is it still
It formats it as a string. So this is all string formatting, but it says it takes the numeric value and it says format this numeric value in the general way, which is kind of like the default way Python prints out numbers when you just kind of ask for it to print out objects and stuff. It's kind of its default thing. Now, you can also specify F. F is fixed point, right? So this is useful for like dollar bills or dollar values because you want 2 fixed values after the decimal. So something like that, and then you write, .8F, .2F, .3F, whatever you want, and it will say, whatever it is, it's going to round off to that many places. So that, if I said X and I said 0:.2F, it would say 0.00, right? It rounds off to two places, 2 fixed places after the decimal point. Okay, and again, you can generalize this to however you want. So all of these curly braces inside a string, they act as replacement fields, and that's what we have. Okay, and then again, you can sometimes in a pinch, rather than dealing with the curly braces, you can just do my age is plus, and then you take string whatever plus this plus that plus this. Okay, this is kind of this first method. It's simple and it's easy to explain, but I would say this is a little bit frowned upon. Okay, but it works, and I won't get mad at you. Okay, so right, and then here again the placeholder indices are optional. So here I've got :S just means turn it into a string, so you can do that with something like this. Oh, and this is, so I had Joe Bruin 183, and it just kind of populates those things. All right, so this is just straight from the Python documentation. So you got 0, 1, 2 with ABC, and it joins them together. Okay, if you don't provide indices, it just goes in that order. If you go 2, 1, 0, it puts them in the index order that you provide. You can also just say, hey, ABC, let's unpack this, right? It treats a regular string as an iterable that can be unpacked, and you can have it unpacked into index 0, 1, and 2, and it matches it up accordingly. Okay, and then here is abra and cad, and if you say, oh, that's 0, 1, 0, now you have abracadabra. Okay. Uno. Okay. You can also provide names. So instead of index position 0 and index position 1, you can give your your fields in curly braces a name. So here I got coordinates latitude, longitude. Latitude is going to be 37.24 N, longitude -115.81 W, and it plugs those in, right? And so inside the format argument, I pass it basically the names and their values, the keys and values. Okay. Similarly, you can create a dictionary with keys and values, and you can take those replacement fields and you can unpack the keywords in dictionaries. So you take any kind of so to unpack the keywords in dictionaries, you got double star, right? Star star quargs for dictionary unpacking. So that's convenient. Okay, and then you also have these less than, greater than, and up caret, which is kind of a left align, right align, and center, and you kind of provide a number there. to say I want the resulting text field to be 30 characters wide, and I want the text to be left aligned, or I want the text to be right aligned, or I want the text to be centered in that character field. And that's what we get here. Okay, but anyway, let's get back to file names. And before I do that, let me give you your second view quiz answer. Oh, my sense of time is all thrown off because this clock is wrong. Okay, but anyway, second view quiz answer, that's fine. Second view quiz answer today is B. B as in bear. Ooh. You gotta get used to this microphone business. Okay, B as in bear. B. Okay. So you can interact with stuff on your computer using the OS module, okay? And so that allows you to interact with the file system in case you need to kind of work with directories. Now, probably a Jupyter notebook might not be the ideal situation for this. You might just prefer to write a Python script or something, and you can kind of execute Python scripts directly from, say, your terminal or your prompt, and it might make a little bit more sense in that way. But sure, we'll just we'll show you how this works. So one is I can just say, hey, what is my current working directory, right? os.get cwd for get your current working directory. And here on my computer, it's stored in users, miles, OneDrive teaching 21, and this is the folder 2022, this and that, right? Whatever it is for you, it's going to be different. When you provide a file name to Python, it's generally going to be a relative path as it relates to your current working directory. So you can provide a file name, and it'll just be something like output.txt, and that's a relative path because it's expecting output.txt to be in your current working directory. But you can technically refer to files in other directories even, but you just have to kind of provide it either the relative path to your current working directory, or you can provide it the absolute path. So so the relative path would have just been output.txt. You could ask for the absolute path, and it starts kind of at the system root, which in our case is my hard drive C, and it'll be C users miles, and then it gives you the absolute path to the directory. All right, and there's more in the OS functions. Oh, what? Let's open this in a new tab. Okay, lots of stuff. All right. So if you have system dependent stuff, you can ask, POSIX being kind of your Unix, Mac OS based type of stuff. Unix based, which Mac OS is. NT will be basically Windows, Java for other stuff. Okay, and then and so some of these things are available only under certain file systems. Okay, but change directory and get current working directory, stuff like that. All right, this is if you're ever interested. All right, so you can just see, does a certain file exist? Memo.txt, it comes back and it says that does not exist. Whereas output.txt, which we created just earlier in the same document, it says that does. Okay, you can check to see if something is a directory or not. So that comes back false. I do have a .git directory inside here, which is where it kind of keeps track of this, and there we go. So that allows you to kind of check to see if certain files exist or don't exist, and that's useful, right? Because if you might want to say, if the file exists, let's read it, and if it doesn't exist, let's create it. Okay, you can list off the contents of your current working directory, and so here You got all the lectures that I've been creating. Okay, I think that's fine. A lot of times when you work with files, and this is just something you got to be prepared for, is that things go wrong. Okay, this is probably one of the most common sources of things going wrong. Is you ask for a file and it doesn't exist. You you want to write to a file and then you don't have permissions to do so, or all sorts of things could go wrong, right? And it could just be like you left the file open somewhere else on your computer, and therefore, like, when you open up a file in another program, you're like not allowed to like make changes to it from a different program, and so all kinds of stuff can go wrong. And then especially if you try to open something on a different computer, you're working on one and you open it up on all sorts of stuff goes wrong. And so it's useful to write your scripts and your code in such a way that you can handle exceptions. Okay. And so one of these things is the try and except. Okay, try this, and if not, then do this. Okay, it's kind of like an if and else, right? It's like an if-else statement, except it's a try, and if that doesn't work, in the case of an exception, do this. And it's more so like, so if else is like if true, do this, and if it's not true, then do this other thing. Try is kind of like attempt to do this, and if it results in an error, don't give me back the error. do this other thing, right? So I'm going to try to open a connection to something that doesn't exist. Okay, so if I say open bad file, which just doesn't exist, right? So it just comes back. Python says file not found error. Okay, exactly what I expected. And rather than, so normally when you run into an exception, it just stops your code. Okay, what you can do with the try except is if this returns an error, the first code chunk returns an error, then don't actually print out the error and stop the code. Just do the code that's written in the except. Okay, so we're going to say, hey, open the bad file. Obviously that didn't work. Okay, now notice 36 doesn't return an error at all. Okay, the code encountered the error and it says, oh, you know what? I was kind of expecting, I was not hoping for the error, but I was kind of expecting it could happen. And that, yep, indeed, we did encounter an error. And you know what? I have a backup plan for this error situation. And what's that backup plan? It's going to be run the code in the except. Okay, and the code in the except just says print something went wrong. Okay, now that's not much of a solution in real life, but we're not getting an error. It says, hey, we have a backup plan. Let's go with that. Okay, and so this just explains exactly what happens, right? You try it, okay, and if everything goes well, then it's going to do what's in the try thing. You don't need to go to the backup plan, right? The backup plan is only if it encounters an error. But rather than encountering the error and saying, throwing up its hands and saying, I don't know what to do, it just says, okay, we'll go with the backup plan. All right, and so this is it's very useful, and you should try it out. Okay. All right, let's take a look at Dbm Databases. Okay, so a Dbm database, this sounds a lot fancier than it is. Okay, it sounds like, oh, databases, and when we hear databases, we think SQL or things like that. It's nothing like that. Okay, this is like the most mundane way of storing information. Okay, it's just like a dictionary, right? But they just called it a Dbm, right? So first you got to import the Dbm library. Simple enough. Import Dbm. It's got a simple enough name that we don't have to import it as something else. And then we are going to open a connection in order to kind of store stuff into it. Okay, and And the option C will create it if it doesn't yet exist. If not, it'll overwrite the existing kind of database file. So we're going to create a file called captions. Okay, dbm.open captions. Okay, and we're going to say create this. Okay, and then basically we're just going to store values into captions, just like we would do with a dictionary. Okay, and so this was. I'm taking this example from the Think Python textbook. Okay, the author of Think Python is a big fan of kind of Monty Python sketches, and so you have like, so anyway, John Cleese is one of the actors of Monty Python. And so anyway, we've got the string. This is going to be cleese.png. This is going to be kind of like the key that goes into a dictionary, right? And so we're going to write cleese.png. It's not a file name, okay? It's just the string of a file name that may or may not exist. And then this value that we're storing is another string, okay? It's just some string that we're using as the key. Okay, and then we're going to, and then later on, if we want to retrieve the values, you just kind of refer to it just like you would a dictionary. So you say, you know, the name of the database file, okay, kind of like the name of the dictionary, and you say, hey, what is the value associated with this key, cleese.png, and then the value associated with that is kind of the caption, which is photo of John Cleese. Okay, it's got this preceding B to say it's kind of stored in, I think, binary form. All right, we can just add another entry to the database. Just like we would do another dictionary, all right? And then again, just like a dictionary, if you want to delete an entry, you can use del, all right? So delete an entry out of the dictionary. Okay, and we can iterate through the database. Oh, you know what? I think later on I created a list. All right, so right now we've got cleese.png, jones.png, and then I've also created a list. When you're done interacting with the dictionary, or not dictionary, interacting with the database, you close it, db.close. All right, and just like and so what this actually does is it's going to create kind of three files. You got captions.back, captions.dat, and captions.dir directory. I don't know. Okay, and these are just side effects of creating a database connection called captions. And so if I say, hey, what are you know, go through, and so this says, you know, list off everything in the current working directory, and if that thing is a file, so for everything listed, if it's a file, okay, and captions is in the file name, then print it out, okay, and so we get all of the file names, including captions. And so you can also kind of, this script can be adapted to search your directories for any kind of certain file name or certain you know, patterns of names and things like that. Okay, now one problem is that the database can only store byte type objects. Okay, and that's kind of what this B, this kind of this B for byte. I thought it was binary, but yeah, byte. It only stores byte type objects, and so if I want to store something like a list, what we have to do is we have to do what's called pickling them. Okay, so it's just this silly idea of like, if you're going to put like cucumbers in storage, right? They would go bad, right? So what you have to do is you have to like pickle them, and that makes them suitable for storage, and then you can put them in storage, and that's, and you know, and now we have this magical, you know, we can unpickle them. But so if you look at the list, right? So this is actually, because I've already ran my script, the database now contains this list, even though we didn't create the list. You can see that the way it's printed out, it's like a mess. We can't interpret this, right? So what we got to do is, if we want to store some other kind of object, right? Something other than a string or a byte, we got to pickle them, and it's going to convert the object into a string that can be written to the database. Okay, so here T is going to be this list with the integers 1, 2, and 3. Okay, and if I try to store the list into the database, it produces an error. Okay, and it says type error, and basically you can't read it, but it's going to say values must be bytes or strings, right? And right now T is not a string. Okay, this result back here, this is the translation of T into a string. So that's the result of the pickling here. Okay, so I'm going to finish a little early. So what we're going to do is we are going to pickle that list with the integers 1, 2, 3 into a string, right? So this is the string representation of T. Okay, we can't read this, right? We look at this and it looks like gibberish, and it is. Okay, but this is what happens when you convert this list 1, 2, 3 into a string. This is what it looks like. But we can store this. We can store this into the DB file. Okay, so now I can take this list, this string, stored into the DBM. Okay, and it allows me to store it. I can close off that connection and close this connection now. Okay, all right. So what do I do to unpickle it? Okay, so I open up the connections to the captions DBM, and I say, all right, I want to get the values out of my list. When I ask for it, it comes back and it says, oh yeah, sure, this is what you stored. All right, and it's this gibberish garbage, right? But I say, okay, well, this is not useful. Okay, so we use the pickle. Okay, and this takes this gibberish garbage, and it says, oh, actually, I speak gibberish garbage, and here it is. It's actually a list with integers 1, 2, and 3 in it, right? So we call pickle.load, and then we feed it in whatever gibberish garbage this is. You put it in, and it translates it into something like this, right? And so this is actually something, if you wanted to, you could like put this into a text message, send it over to someone, and if they painstakingly typed it all out, it would come back and be turned back into, you know, this list object with the integers 1, 2, and 3. So all of that information is stored in there. Let me go ahead and give you your last view quiz answer. Today's last view quiz answer is the letter B. B as in bear. B as in bear is your third view quiz answer. All right. You can also pickle objects directly to a pickle file, and you can pickle multiple objects by first grouping them together into a list or a tuple, right? So you can pickle any kind of object, and you can even pickle tuples and stuff. So, for example, object 0 is going to be a list with 2 strings in it. Object 1 is a list with integers 1, 2, and 3. And object 2 is just a string by itself, right? So here we're going to create like a new pickle right? Not a DBM, but just a new pickle object. Okay, and we're gonna write to it, write as into byte format as a file, and then we're gonna just do pickle.dump, which is the way we kind of convert things into pickle things, right? So pickle dump. So dump s is you dump things into string format. You pickle them into string format. So this is dump s, pickle dumps. Okay, it's not the greatest choice of names for the method, but that's what we're doing. So we're pickling our dumps as strings. And this one we're pickling as a pickle dump directly. Okay. And so we're going to just kind of group those three objects into a list. We store it as a file. All right, that's objects.pickle. And then we can load the pickle. All right, so now we're opening the connection with RB, right? So because I used with, the connection gets closed just automatically. And so now when I load it, okay, I unpack it into the tuple x1, x2, x3, and x1 contains that first list, x2 contains that second list, and x3 contains that last list. Okay, and so this allows us to kind of store objects for usage for later. Okay, and a lot of times when you have a Jupyter notebook, you don't think about this kind of stuff. But sometimes, this is useful if you had to run some kind of computation thing, right? And it took a long time. You had to sit around for 10 minutes or whatever for all of these computations to run. And you don't want to have to rerun all of those computations, but you want to store those results, right? So one way to store them is to store them using a pickle to store the objects or the values in that result there. Okay, we'll go ahead and end here for today. I think I gave you all three view quiz answers. Yeah, question. Oh, is it? Okay, I got to figure this out. All right. Thank you for pointing that out. You are right. Let's change that. Okay, it should be open now. It should be open. All right, and I really hope this thing's saved. So let's see. Stop recording.